Greetings everyone, welcome to the fifth part of the video for section 8.1. We're just going to look at one more example of using the law of cosines, which you see right in front of us here. Alright, so we're going to look to find the area of a triangle, which at first this may not seem like it requires the law of cosines, but it will be a helpful tool for us here. So we're asked to find find a triangle, find the area of a triangle that has side lengths 7, 8, and 9, where those units are all in inches. And just like we've done in past problems like this, to give us a visualization of what's going on, we're going to go ahead and draw a triangle. So I'm going to make it look like this. I'm going to say that this is the side of length 7, this is the side of length 8, this is the side of length 9. And we're being asked to find the area of this triangle. And you may recall that the formula for area of a triangle, or one of them at least, is 1/2 base, whoops, that was whatever that was, base times height. And in our triangle, and the way we've got it oriented, I would say the base would be this bottom side here, which looks like it has a length of 9. But the height would be an altitude of the triangle dropped down from here, intersecting the bottom of the triangle at a right angle. And in this picture, we don't actually know what that is, right? We could maybe try to guess, but we'd rather be more precise. And in order to help us find that, it'd be really nice if we knew the measure of this angle right here, right? Because if we knew that angle, well, that's inside of a right triangle, right? A mini right triangle there. And we could use that along with that angle, along with the length of the hypotenuse there to find the height. But again, we do not have that measure of that angle. However, we can use the law of cosines to help us find that. So let's see, the way I've got this labeled, that's alpha, which means the side opposite, it has to be A. And it doesn't matter how I do these, I call the 7 B, the 9 C. And so if you recall from the previous video, we had that by the law of cosines, A squared is equal to B squared plus C squared minus 2 times B C times the cosine of alpha. So we can go ahead and fill in all the information we have. Whoops. So we know that the value for A is 8, so we have 8 squared equals B, which is 7 squared, plus the value for C, which is 9 squared, minus 2 times 7 times 9. But this time we don't know the measure of alpha, so we'll just leave this as cosine of alpha. Okay. And notice what we have now, again, is we have an unknown over here, alpha, or the cosine of alpha. We were able to fill in everything else, which means we should now be able to solve for the value of alpha. So let's work this out. We have 64 equals, here we have the 7 squared plus the 9 squared, be 49 plus 81, which gives us 130. And then the minus 2 times 9 times 7 gives us a minus 126 times cosine of alpha. And I'll tell you right now to be very careful. Okay, students will often want to subtract these two things here, this 130 and the 126. We cannot do that. And why, you might ask? Well, that's because the 126 is being multiplied by this cosine of alpha, right? And we don't know what the value of alpha is yet, so we can't subtract it with other things. So what we can do instead, because we're trying to solve for alpha, is actually subtract 130 from both sides of the equal sign. And these will cancel. 64 minus 130 will give us a negative 66 equals negative 126 times cosine of alpha. And then we can divide by negative 126 on both sides. And these will cancel. So now we'll have cosine of alpha equals negative 66 over negative 126, which a negative over a negative makes a positive. Reduce those two to make 11 over 21. So we have cosine of alpha equals that, so we know to find alpha. We can do inverse cosine of 11 over 21, which if we plug that into our calculators, then we'll get 58.4119. Okay, and that will be the measure of angle alpha over here. 58.411. All right, and then we can go about using that to help us find the height. Now, before we do that, I want to revisit something we talked about in the law of sines when we did our inverses to find angles. Just remember with the law of sines, there was a possibility that there could be two different triangles once we find this angle measure, right? Well, is that possible with the law of cosines? Well, let's think about this. So that 58.4119, that's in the first quadrant because we're taking the inverse cosine of a positive number. Where else is cosine positive? Oh, that's right, in the fourth quadrant. And if you think about it, angles in the fourth quadrant lie in a range of 270 degrees to 360 degrees. And could we ever have an angle in that range inside of a triangle? Hopefully you're saying no, right? Because that would be too large. The sum of the angles in a triangle are no more than 180 degrees, and so we can't have an angle that's more than 270 degrees in the triangle. So in this case, we only have one answer. All right, and now we are almost finished here. Just need to, again, find the value for h, and then we can plug in the info into the area formula. Get this all erased here. Okay, so again, we need to find the value of h right here. And in this triangle I'm outlining green here, that's a right triangle. You know, the h is an opposite side, 7 is the hypotenuse. And so we can say, ooh, not that, because that is not readable. So we can say that the sine of 58.4119 is equal to the length of the opposite side, which is h, over the length of the hypotenuse, which is 7. Can then multiply by 7 on both sides. These will cancel. So end up with h equals 7 times sine 58.4119. Should we multiply that? Will give us 5.9628 inches as our height. So we know that this is 5.9628. And now we can plug in the information into our area formula. So it'd be 1/2 times the length of the base, which as we said was 9, times our height now, which is 5.9628 inches. When we multiply all of that out, looks like we end up with 26.8326 as our area. And because our units are inches up here and we're finding area, we recall that this is inches squared. Okay, that's our answer. All right, that is it for now. Thank you for watching.